But how's everyone doing? Did anyone have trouble with the homework from last week? Or any questions about Notice to Mariners or the chart 1? Did everyone navigate their way looking for things around the chart?
You actually have the answers in there too.
Yeah, you have the answer. I did get a couple of those questions. I am not grading anything. You don't have to submit your homework. These are just exercises for your own benefit, just so you can practice what we talk about during the lecture. So, but if you guys have any questions, it's a way to practice what I'm blabbing at you about. That way you could come up with some questions if you don't understand it. So the answers are there for you, and it's a great way to, you know, so you don't start going down a rabbit hole of the wrong way, to check yourself as you go with the correct answer. That way it's a study tool, I guess. But yeah, there's no pass or fail, there's no grade. This is just a fun class. I hope it's fun class.
Bree, I do have one question.
Okay.
Sorry.
No, go ahead.
Okay. Bree, there was one question, question 18 on the assignment 2, referring to one of the buoys. And what I was questioning or had a question on is it has an indication. I understand that it would be, I assume it would be a lighted green buoy, but then it has in, I would almost say quotes, 3. Would the 3 indicate the height of the buoy? Or would that be the sequence of the flash, 3 seconds?
Neither. So I'm going to show you on the share screen here. Okay, so let's try to zoom in here. So he's looking at, all right guys, hold on. He's looking at the homework assignment on number
18.
18. Get this focused here.
Yep.
Okay, so we have the buoy symbol, right? That's that, this is our buoy,
yep,
right? And then it had that magenta circle over it, meaning that it's a lighted buoy.
Yep.
Right? And then the words that it had the first line was our G and our 3, and then our second line was 2.5S. So when we look at this, zoom out a little bit here. The first line is describing the physical buoy that we are seeing. So in daylight, what physical buoy are we going to see? That buoy is a green buoy. And anything that's in quotes is what is physically on the buoy.
Oh,
so there is physically a number 3 on the buoy.
Okay, sorry, thanks.
The buoy, the safe watermark that we see a lot, it has the NWP because it literally says NWP on the buoy. So anything in quotes is what you're actually looking at. So this first line is describing the buoy. It is a green buoy and it has a number 3. Say it was a nun or a can or whatever else, that would be on the describing buoy level. Then this section is describing the light. So the light is flashing, it's green, and the frequency that it's flashing at is 2.5 seconds. And we're going to go over today some other light characteristics that will be seen. So this section is all about the light, and this section is all about the buoy.
Okay, thank you.
Yeah, good question.
Can you go straight across to 8?
Yep.
It's got the 6, red. I just couldn't figure that. What is that?
Okay, so I don't know if you found this on your guys's, but the printout missed some of the things. I'm gonna have to find, I will draw a picture of it. I'm gonna go to the Google Classroom real quick.
Oh, it's not even on there. It's on mine.
Number 8.
Yeah, it
Let's
shows
see.
up on mine.
Okay, it's not on. Wow, I'm looking at it. Okay, so it's a red day board, and a red day board is going to look like that. Yes. So that, oh, you can't see. Can you see my whiteboard?
Yes.
Okay. Oops. Jeez. Oh. Okay, so the red day board, I know it doesn't, my printout doesn't have it, but it's basically going to be a triangle, and it might have an R next to it for red. Some charts you might have will make it a magenta triangle with an R, but we're going to go over our day boards, and our red day boards are triangles, our green day boards are squares, and it will have a G describing the color of it. So yeah. I will try to fix, I guess number 4 didn't, I guess there's a few on here that the image didn't really turn out. So I will try to fix that. I'm sorry about it.
It is in the printed stuff.
Okay. Good. At least it's not all screwed up.
Captain
never
Bree,
know what
question
Gets
2.
a little messy. What was that?
Question 2 on the same page.
Yes?
It shows a submerged, what was it again, a wreck, partially submerged wreck. What is the circle on the bottom of that? The white circle? I couldn't find that on the chart for that actual symbol.
I don't think there's, okay, so I'm seeing this one is bad.
Because in a buoy, it means fixed, right? Or like,
Oops. Sorry, I'm bringing it up on Word. Hopefully, okay. So let's do this, and I will share this screen. Share screen. Okay, so let's zoom in here. Okay, so the whole thing is the symbol for a submerged wreck.
Okay. Well,
So-
what's the circle on the bottom of it?
This white circle right here,
Yeah.
that's just saying the location of it. That's just part of the symbol itself. I understand on the it just kind of depends on what version of chart you're looking at and chart symbol that will have either that dot or not have that dot,
Oh, okay.
that white circle. So maybe this image that I put up there came from a newer chart, or I'm trying to find the rest. There's one, this one.
Okay, thank you.
Yes.
May it never represent any of our vessels.
This picture?
Well, you hope not.
Right, may it not.
Okay, so
I have a question on 9.
so on this guy, there is a little white circle on the one that I have. So it all just kind of depends on which chart 1 that you're looking at. So, Milo, did you have a question?
On 9?
On 9.
Yeah, I mean, I found where it has a radar transponder, and I'm guessing, I don't know, is it sending out MRASS or something on Morse code, or what's that?
No, that's going to be the type of radio that it's sending out, like a frequency kind of thing, I think.
Well, I couldn't find that anywhere.
Yeah. I don't have a good answer
right.
for you on that one.
Okay, okay.
Well, look, this is an older chart. So when we look at like the Raycons and the extra information that we'll use on the Long Beach San Pedro channel chart, it will make more sense. Like I forget which light it is on the entrance to Newport. You can like radio and the light will go off, or the horn will go off or something, and it makes more sense. I'm not sure off the top of my head what MRASS stands for. Does
Captain,
anybody else know?
I think it was in the book somewhere. I don't remember what it stands for though.
Okay.
quick question, Captain.
Yes. Go ahead, Sam.
Any of the beacons, do they transmit Morse code either in a radio signal or light signal flashing?
So some of the light characteristics, for example, the safe watermark, it says Morse A. That light characteristic is a DIT-DAW for all safe watermarks. So a little, a DIT, and then DAW, a short, long,
Yeah.
for all safe watermarks. When you get a Raycon, example, this is a Raycon, that's going to be on a radar. When you have a radar and the radar intercepts this light or this buoy or whatever it is, it will send out a signal on the radar in the form of this Morse code. And I'm pretty sure I have some pictures of that.
So MRASS stands for Mariner Radio Activated Sound Signals.
Activated what?
Mariner Radio Activated Sound Signals.
Sound signals.
Right.
Okay, so it's somehow this sound signal is somehow activated by marine radio.
Yeah, we do that in piloting as well, in
Yeah.
planes. You are contacted over a certain frequency, and it will start replying, turn itself on.
Oh.
And we have one of those at the entrance of Newport.
Yeah.
Let's turn it up real quick. Sorry, hold on. Bear with me a second. Oh, it went to the wrong one. Dang it. Sorry, hold on. Any other questions while I'm trying to bring this thing up? Okay, good. I will answer this one.
Hey, Bree, I had a question.
Yes.
On assignment number 1, item 18, what U.S. government agency prints charts for areas outside of U.S. territorial waters? I was unable to find that, and it was weird. I remembered reading it, and when I went back through to try to get the right answer, I couldn't find it again.
Okay, so I'm gonna say it's NOS. Is that right?
NOS?
I'm pretty sure it's produces the chart. Oh, NGA.
NGA.
NGA is the one that produces outside. A lot of other charts you might see are the BA charts, or the British Admiralty.
Okay.
There's a lot of those out there. If you're just going up into Canadian waters, Canadian Admiralty, they have their own charts. But NGA will print Canadian charts as well.
How about for the Mediterranean? Would NGA print?
Those would be either NGA or British Admiralty.
Or British, okay. Thank you.
Yeah. You can get a chart catalog. Again, when I'm in the classroom, I have these chart catalogs that you could go through. But you can get one. Well, the NGA one and the BA one are very large, so those aren't free. But the NOS ones are. But you can get it, and it can identify which charts that you are looking for if you're going to the Med.
Excellent. Thank you very much.
Okay. So I'm sharing the screen of the Newport, and I was trying to remember what it said on this buoy, and it does say that MRASS. So we will try to remember what that marine radio activated sound signal, C-Note K. So it explains it a little more on C-Note K. But yep, the entrance, the day beacon with the light, number 3, has that marine radio activated sound signal. So let's zoom in. Okay. Well, shall we get started on week 2? I don't know. In your guys' packets, did you get a handout, a aid to navigation handout?
No, we need that.
Okay, so it is on the Google Classroom, and I will email it to you if you. I know Kim and Tim both need the email. So I usually pass them out in class.
Yours is in color, and the illustrations in the book are not. So I was glad
Right.
to see this.
Well, they told us to color them in. It's
Oh,
part
they
of
did? I didn't
the
see that.
learning process.
It had like a line red with a line. I see. Well,
Oh gosh, oh gosh. So these are also, if you have the light list, there's some great, some of the images I have are in the not the light list, the chart 1. If you have a light list, this is in the first pages of the light list. Most people don't have the light list, so, but they're a ton online. I posted them on Google Classroom. I will send them out to you guys, but some people have was trying to find it's like a hard placard that you could just keep on your sailboat. This one's for Celestial, but the quick reference materials they have for the aids to navigation as well. I just can't find that one right now. But in my lecture, I might say you can, make notes on this, but I understand that you guys didn't get it. So let's do the PowerPoint. Let's get into it. Okay. All right, so do we have the PowerPoint? Can you guys see it? Great. So today we are going to start talking about aids to navigation. So what kind of things are out there that help us know where we are and know how to behave, and how we could expect other vessels to behave and basically help us navigate. So we don't go too much into collision avoidance in this class or rules of the road, but the aids to navigation do help understand what we're going to be anticipating. So I kind of talk a little bit about that. And then in the second half and part of this PowerPoint, we're going to talk about our plotting tools and plotting latitudes and longitudes and course and direction. So we got a lot to do today. I think we can get through it and start the homework. I might talk a little faster in the lecture, but I am recording this, so this will be posted on the Google Classroom as well as the YouTube channel. So even if you don't have Google, you could just Google Bree Bennett, and my YouTube channel will come up with the tutorials and recordings. Okay. So let's dive into it. Okay, so we have two buoyage systems. We have the cardinal system and the lateral system. So we're going to focus mostly on the lateral system, and that lateral system is talking about, which side of the channel are we supposed to be on laterally. And in that lateral system, we have two areas. We have area A and we have area B. If you are in area B, which we are, and I'll show you a map in a second, we use the term red right returning. Has anyone heard this before? Hopefully a few people have.
Yes.
It's the common red buoys, red lights on the right side when you're returning from sea. So that rule only applies in area B. If you are in area A, you have green right returning. So I just want to throw out there that you want to know where you are navigating, because our red right returning doesn't work worldwide. So today we're gonna focus on our red right returning, area B, but I want to say before we start this, there is an area A that doesn't follow all of our rules. And we're going to go into some of the cardinal marks as well. Okay, this is our map of region A and region B. So B, we have North and South America, and then we have Japan, South Korea, and some of the Philippines. Everywhere else is going to be A. So if you're in the Med, you're in Europe, and down in the South Pacific Islands, you're going to be seeing green right returning. So keep that in mind. With that in mind, we're focusing on B today. Okay, So Iola B, the Iola B system, when you're returning from sea, so when you're headed inshore or inland, everything on the right-hand side is going to be red. It's also going to be even numbers. So you start with your 2, 4, 6, and your small numbers start at the sea. The higher your numbers get, the closer inshore you are. So, you know, your number 1 doesn't start at your dock and goes out to sea. The number 1 starts at the entrance of the harbor and increases as it goes into the sea. Excuse me, into the harbor. Another one of these poems that that people like to say to remember this is, even red nuns have odd green cans. So we're also going to be talking about the shape of the buoy. So I'm going to be doing this a lot. We are switching. Okay. You can see my whiteboard, right? Okay. So we have a can buoy. Make sure you can see this. Nope, you can't see it. There we go. We have a can buoy versus a nun buoy. So our shapes are different. These are really offset, but we have squares and we have triangles. So our right side is red, our left side is green, and the shape also has to do with the numbers. Our numbers are odd, 1, 3, and our numbers on our right side are even, 2, 4, etc. So let's go back to the PowerPoint. So to remember this, we can go with even red nuns have odd green cans. Or we could just remember red right returning, and the opposite, if you are not returning, it'd be green.
Hey, Bree.
Any questions with that?
Yeah, in the A group, so for example, over in Europe, when green is on the right, are they still cans and still odd numbers? They're just on the right?
Yes, and the numbers are the same as well. So
Okay.
Let me show you on this guy. So it would be, instead of like this, there's your buoy with a 1.
Oh, so the nuns over there are green and even.
Yes.
I see. Okay.
So the color is different.
The color is different, but everything else is the same, and it's on the right.
Yes.
Okay. Thank you.
Yes.
Question, Captain. Just to clarify, the buoys numbered, they start 1 when you get into harbor?
Yes. So
So the further out to sea, it's higher numbers?
no.
It's the other way around.
Other way around. Yes.
Okay.
So let's see. Here's the ocean. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, etc., etc. So the further you go into shore, the higher the number will be. And I know I have a picture of that. Okay, keep going. Okay, lighthouses, just real quick on lighthouses. They have lots of different identifying things with them. Their shape of the lighthouse, the paint pattern, the light on it can be green, red, white, yellow, and they can have different sectors. We don't see too many sector lights here on the West Coast, but on the East Coast, and if you are taking your 100-ton tests, you're going to be seeing sector lights on those chart plots. Where if you see the light and it's red, it's telling you that you're probably in a dangerous shoal-like area, or you could be, it's a possibility, depending on your danger bearing. Versus if the light is green, you might be in a safer area. So that's the point of a sector light. But again, on the West Coast, we don't have too many of those. These are some examples of the White House. I'm not going to read all these things. You do have the PowerPoints, but all different things to identify that you are looking at the correct light. Lighthouses are great aids to navigation because they are easily identifiable. They're bright, they're tall, and they're easy to identify. So we always want to make sure the light that we are seeing from the boat is the light that is on the chart. So it's very common mistake to misinterpret the chart that you are looking at the wrong light and put it wrong on the chart. So that's a very common mistake, but we like lighthouses because they're easily identifiable. Okay, I'm gonna skip this. I'm not gonna read all of it. So looking at our Iola B system, on the left-hand side of the channel, as we are entering, we have our green odd selection of things. So we have a day beacon with a number. So you can see the symbol there is green and a square. Depending on what chart and what print you are looking at, the square might be colored green, but it might not be. It just depends on what chart that you have. It might just be a black square or an outlined square. But that G is telling you that it's a green day beacon, and then anything in quotes is what is physically on the buoy or day beacon. So if that day beacon has a light, then that would be a fixed light. Remember that solid dot means it's fixed on the sea floor, where that open dot is a buoy. It is floating, anchored with a chain, rope, some sort of road. So even though this is still a day beacon, it has a light, so it is going to be shown as a light symbol. But then it has what it is in quotes. In quotes, it says it's number 1. So it doesn't have the square this time, but it has that you will be seeing a number 1. And then it has the light characteristics. So that light is going to be flashing green every 6 seconds. So the first part is describing what you're seeing. A fixed object, it says number 1. And then that second line there is describing the, light characteristics. Then we have our 2 buoys. We have a lighted buoy that has no specific shape. It's just a standard buoy. And then you have a shaped buoy. So we'll talk about the shaped buoy first, is a can. So it has a squared off, kind of squared off if you're looking at it, edges, versus the nun is going to be more triangle shaped or have those sloped edges. The can is squared edges. So this description is describing the buoy itself is actually green. The C stands for can. It is in the shape of a can versus a nun. And you're physically going to see the number 9 on it. So all of our green have the odd numbers on it. And then you just have your standard lighted buoy is going to be colored green. So some buoys are colored red, some buoys are colored green. They don't have a specific shape to them. They're just colored. And then their number tells you what the color and the number gives you the information of where it should be. So this first line is describing the buoy. It's a green buoy and it has a number 9 on it. That second line is describing the light. And we know it's light because it has that magenta stamp over the buoy symbol, indicating that it is a lighted buoy. It's flashing green every 4 seconds. So
And is there any is there any reason for the light except, I mean, if you see a lighted buoy, is that more important, or just that harbor has more cash, or I don't know.
I would say yes. That in an area that's probably less like high traffic, big ship traffic lane are going to have all lighted buoys. Okay. You're going to see the can buoys on, I would say, smaller boat areas, less traffic. Okay. That's just what I am saying from my experience. I don't know if there's a rule of if an area should have lighted buoys or unlit buoys. Okay, this is a graphic of your, green lighted buoy. Again, it's just a buoy shape. And then you have your can, and this is actually a spar buoy, which there wasn't a symbol of, but same type of thing. Okay, so on our right side of the channel, as we are entering the channel from sea to shore, the right side is going to have even numbers, and we're going to have a none shape, and our shape on the right side is the triangle. So our shape is more pointy, right? The right side is going to be pointy. We have the day beacon, which doesn't have a light. We have the light, a day beacon with a light. And then we have the none buoy, no light. And then we have a lighted buoy. So same characteristics that I went into last time. I'm not going to read them out. There's some graphics. I put this one in here. I get questioned a lot. What is a dolphin when referring to aids to navigation? It's just kind of this pillar. Instead of a one post, it has multiple posts. That is what they call a dolphin. Some you might see, or I used them a lot on larger vessels for different moorings. If the dock ran out, but our bow was past the dock and we wanted to put some bow lines out, there'd be a little catwalk, if you will, a little passenger walkway to another dolphin that had some bollards on it or something like that. So it's just a term of a pier, wharf, a dolphin. It's just a term, so that's why I threw it in here. Your aids to navigation lights, your light list or your list of lights. Remember, list of lights is for the foreign places that you're going to be traveling. Light list is for United States waters, and they will have descriptions of the exact locations of all of our lights. They won't have the exact location of the buoys because our buoys are not fixed objects, but they will have the light characteristics, the physical characteristics, your radio signals, all sorts of different information for each light. So if you see a symbol on the chart and you're curious you want more information about that light, you can look it up in the light list and get more information. Then there's digital light lists. that you can just like control find and quickly find one. You don't have to thumb through the book. But if you don't have it, you know, digital power, you could always look at the book. Okay. So now we're going to talk about a little bit about intercoastal waterways. Again, here in Southern California, we don't have intercoastal waterways, but pretty much everywhere else does, or specifically the East Coast. And oops, let me get this. Oh, cool. Specifically, the East Coast and the Coast Guard likes to pretend we're all on the East Coast. And then if anyone has gone from Seattle to like Ketchikan, you could go on the Inside Passage, and that's an intercoastal waterway going, so you can go all the way from Seattle to, or pretty much Tacoma, way south, to Ketchikan through Canada all the way to Alaska without actually going into the Pacific Ocean. You can just travel on the Inside Passageway. That's what the Alaska Marine Highway does. There's a lot of cruises that do that. It's really pretty. And then on the East Coast, there's lots, East Coast and Gulf Coast, there's lots of intercoastal waterways. So when we're talking about the intercoastal waterways and the number system, with the entering a channel system, your small numbers were at the entrance of the channel, and then your larger numbers went, the deeper into the harbor you went, the larger they got. With intercoastal water system, intercoastal waterways, your returning is going to be kind of like a clockwise motion around the United States. So here's my picture of it. So if you're traveling intercoastal waterways, your numbers are going to be increasing. Your triangles are going to be on the shore side. Your squares are going to be on the ocean side for the whole way as you are rotating clockwise around the United States. Does that make sense? Okay, hold that thought. I'm going to show you some pictures. Wait a second. I have to show you the picture. Hold on. Okay. Share screen. Okay. So this is on the back of your paper if you had printed it out. But this is describing, we'll talk about the basic buoys first. We have our safe water mark, which I will get to. That's kind of the entrance of the channel. It's safe water. And then on the right side, we have our red buoys, even numbers. So we have even number, even number, even number, even number. And then we also have our lighted day markers, the 2 and the 1. Again, odd numbers on this side. So if you were going intercoastal waterway, this would be traveling basically from east to west here. So our even though this is a red buoy, it has that little yellow symbol on it. So you see the yellow symbols? Those are going to be our intercoastal waterway symbols. So that comes into play when you get into a situation that you're crossing like a preferred channel here, when you have a red buoy on the right, which is good, that's what you want, and then all of a sudden you have a green buoy on the right. But if you're in the intercoastal waterway, that little triangle, that yellow triangle there, is the symbol that you're following if you're on an intercoastal waterway. And I'm going to dive deeper into this, not too much, but in a different slide. I'm going to go back to, bear with me here. Okay. So generally thinking, our intercoastal waterways goes clockwise around the United States, where our harbor system starts at the entrance of the harbor, gets larger as we enter the harbor, and we follow our red right returning, green odd cams. Okay, now we're going to talk about those cardinal marks. So I was just talking about lateral aids to navigation, the lateral marks. Now I'm going to talk about cardinal marks. So these cardinal marks are going to be the same worldwide. So there's no A or B system on the cardinal marks. These are going to be everywhere. Our first one is our safe water mark. Our safe water mark is pretty much at like the entrance of a main harbor or a highly trafficked harbor. Sometimes people will call it, if that it's an area like a pilot buoy, that's where a lot of times people will drop off pilots, pick up pilots. So there could be a lot of traffic around this area, even though it's saying there's safe water, meaning you can pass on either side of it. You don't have to keep it to the right. You don't have to keep it to the left. There's good water all around it. The things we want to keep in mind for our safe water mark is it will always have a white light. So it is not green or red. The light is always going to be white. And the characteristic is always going to be Morse code A. So that's hit da, hit da, hit da, and not a specific frequency. Just a small flash and then a long flash. Small flash and then a long flash. We also, characteristic of a safe watermark is that it is vertically striped. So it is red and white in vertical stripes. So we're going to talk about horizontal bands as well as vertical striped things. So the safe watermark is always vertically striped. If it's a buoy, if it's a ball, if it's a day mark, it's going to be hard to have a day mark with a bunch of safe water around it, but I guess it is. So that's a safe water mark. So we'll be finding those specifically on our Long Beach chart, our Newport safe water mark, our Long Beach, LA safe water marks. We'll be looking at those a lot. Here's some examples. Okay, what I didn't talk about, this symbol on the top is called a top mark. So the top mark, some of these cardinal marks are going to have top mark symbols. So that is another shape that's going to be on the top of the buoy, giving us some more information. So in this case, it doesn't have to have it. Again, this one doesn't have a top mark. This one has the circle top mark. Also doubling as a radar reflector, but that's what a top mark would look like as well. Okay, preferred channel marks. this is my caveat. This is not a cardinal mark because the preferred channel marks go with your read, write, returning IALA A, IALA B system. But your preferred channel marks is saying that there's a secondary channel and there's a preferred channel. Maybe the deep draft big ships stay in the preferred channel, but there is safe water and you could go to the secondary channel. They're just going to leave your read, write, returnings on the primary or the preferred channel. So it's kind of this, you can turn right or you can turn left. Which way should I go kind of direction. So how you define that is the main color. So if I have the main color as red on the top, red on the bottom, and it has that triangle shape, and I want to stay in the preferred channel, I'm going to treat it like a red buoy, a red triangle, a none. That is telling me that the preferred channel is to port, that I'm going to keep that buoy on my starboard side, keep it on my right side. But I can put it on my left side with that green and go in a smaller channel or secondary channel. So it's still possible to treat it as a green buoy. And then your, your preferred channel to starboard is going to be the green on the top, green on the bottom, and cylinder shapes. And then you can treat it as a red buoy, but the preferred channel is to keep it to the left. Okay.
Hey, Bree.
Yes.
Quick question, if I can back on the cardinal mark. It's designed to tell you where from that buoy is the safe direction away from a hazard. Is that right?
No, we are going to get to those ones.
Okay, we're going to cover it later. Okay.
Yes, momentarily. Okay, so these are your images of the bifurcation. Oh my gosh, I can't say that word.
Mm-hmm.
Bifurcation marker. Okay, it's going to be one of those nights. Okay, this is another cardinal mark. So isolated danger A and B. So this is how it is explained, an isolated danger. So it's not marking a large area of shoal water or large rocks. It's an isolated danger. Maybe it's a wreck or some sort of sunken something or other. That's just an isolated danger. So that's going to be your horizontal bands. So we have black, red, black, and our top marks are the two black spheres. There's an example of our isolated danger. And we don't see too many of these cardinal marks on the west coast of the United States. But if you're traveling elsewhere, you'd see them. Okay, I'm almost to your question, Dave. Special buoy marks has a top mark of an X. There we go. Used to mark special purpose areas. It says here traffic separation schemes. Not all traffic separation schemes are going to have a special purpose mark. I would say not many on the West Coast here have this at all. Maybe over in Europe, I'd say, but military zones, special anchorages, it's just some special purpose mark that if you see, you'd want to go to your chart and it would have probably some sort of information, C note A, C note B. It's giving you information about that specific area. So just a general special purpose mark. Then we have our information or warning buoys. So these are the buoys that we're going to see a lot in, recreational boating harbors. We have speed limits. We have, no wake zones, swim areas, that kind of information. Just information markers on with this white with the reddish orange, white with red. Okay, now we have our indicating hazard. So this is what you were talking about, Dave. If there is so looking at this picture, the buoy would be on top of the marked danger. So if it would be safe to pass this danger to the north, if this is your safe passage, then it would have this buoy. It would have the buoy with black and then yellow, and the two top marks being triangles pointed up. That would be your north. It's safe to pass to the north. Safe to pass to the east is going to be your diamond shape. Safe to pass to the south is going to be your triangles pointed down. Safe to pass to the west is going to be your wine glass. Okay, it's not called a wine glass, but west wine glass. I don't know if that's a helpful memory aid. Your triangles apex together is technically what it's called. And you also have the bands, and then your light characteristics that go along with this kind of correlate with the clock. North is just a constant quick flashing. East, 3 quick flashing. To the south, 6 quick flashing. And to the west, 9 quick flashing. Again, this mark would be on that danger saying safe passage is to whatever direction it is pointing you to. We're not going to see them on the East Coast, but you might see them also. Or you're not going to see them on the West Coast here.
Question, Captain?
Yes.
How far away do you have to be from the buoy? Is it something or?
That would be up to you as the navigator and what your comfort level is. It doesn't say on this, is this mark, is this danger, widespread or not. Hopefully it would indicate that on the chart. But that's your comfort level and the maneuverability of your boat. Maybe, what kind of depth sounder do you have on board? Is it reliable? Can you, are you maneuverable? Can you stop and turn? Can you go astern quickly? Some vessels can't go astern quickly or stop or turn quickly. So that all has to come into account of how close you want to come to something. Recreational boating, you tend to go pretty close to buoys because it's easy to navigate towards the buoy because you have something to look at. Me personally, I don't like getting close to buoys, but that's because I'm a big boat person. But I know a lot of recreational boating have no problem getting close to buoys. I don't like to. I don't know. That's my 2 cents. Okay. Okay, so pop quiz. Where's the safe water on this cardinal mark on the left-hand side?
East.
East, yeah.
East. That is triangles apexed away from each other. What about the one on the right?
South.
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 Good, good. Okay. Okay, this is a stretched out picture of that that guide that you can get online. You can get the waterproof copies of it. I would recommend keeping one on board just as a good reference for you guys. Okay, now we go back into that intercoastal waterway. We kind of have our slides mixed around here. Okay, so our preferred channel is this orange arrow. We have our red on the right, we're turning from sea, our numbers are increasing, even on the right, odd on the left. And then our intercoastal waterway, we're following the little yellow symbols. That little yellow, little yellow, little yellow. That's what we're going to be following on the intercoastal waterway. So to stay on the intercoastal waterway, we're keeping the triangles on our right side, squares on our left side.
So it's 7 and 8, is that going inland?
Yes, so this arrow is pointing our
Land.
Excuse me, our preferred channel, right? So with smaller numbers closer to sea, larger numbers closer inside the harbor, and then our seaward channel, a lot of times the numbers won't match because these numbers are here for the preferred channel. So if you have other buoys along the way for the intercoastal waterway, they're going to start in that clockwise motion. So the further, north on the East Coast, the smaller they are. As you go south on the East Coast, the larger the numbers will get. But not all those numbers will correlate with one another because the numbers mean other things for the primary or secondary channels. You have like primary or preferred waterways, secondary waterways, and then intercoastal waterway. You have all these streets going, right? You have like a freeway, a highway, and a city street. You have all these sizes of streets moving along, and they're all connected, but we don't have like on ramps and off ramps like we do on the highways. So this is our intercoastal waterway. Okay, here we have our preferred channel, or excuse me, not our preferred channel, our safe watermark as the entrance to this harbor. Also, I didn't go over, but these two things, what we have here, are called range lights. And if these are in line, then we are entering the channel straight, which I think I'll go over to in a different lesson. And then we have this bifurcation marker. Can someone say that so I can copy them?
Bifurcation.
Bifurcation. There we go. Thank you. Bifurcation marker. So we have the preferred channel is to treat it as a red because we have red on top, red on bottom. This is red. We'll treat this as red, 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 red. We're going to stay in the preferred channel. We can go to the secondary channel and we can treat this as a green. So we have a green buoy, a green buoy, a green dayboard, and we can treat this as green going this way in the secondary channel. And then we have our intercoastal waterway with these little yellow markers. We have the yellow square, the yellow triangle as we go this way on our intercoastal waterway. Now we're looking at it at night. Same image, it's a fictional chart. Same image, but at night, or not at night, from a chart. Do I have a night one? No. This is just on a chart. So on a chart, it's going to look like this is our isolated danger. This is our bifurcation. We have red and green. So it doesn't say red, green, red, but the red is first, meaning that's the primary one. And then we have our safe water mark symbol. We have our light symbols. I don't know what else we have here.
And all this is opposite, right? If you're leaving the harbor?
Yeah, well, so, the buoys stay there, but if you're
Right.
leaving the harbor, your numbers will be getting smaller, and you're going to have the green on your right-hand side.
Okay.
Bree, not to confuse things, but also is with that bifurcation marker, could you have it where the symbols would be reversed, red on top or green on top and red below? So that would change you to a different channel?
Yes. Yes. So if it was green, red, green, it would be saying that this was the preferred channel.
Okay.
If it was green on top, red, and then green, the preferred channel would be keep it as a green.
Okay.
Did that
thank you.
answer your question?
Yes.
Okay.
So the preferred
Captain?
channel always goes on top, essentially.
Yes.
Captain?
Yes.
So if you're on that
top and bottom.
I have a question. So if you're on that intercoastal path going from right to left and you're crossing the preferred channel at night and you're seeing two red buoys, is that right?
Right here. Is
Yeah.
what you want.
What's your indication? Like you're cruising along, what's your indication to say, oh, that's, I guess I would be confused really quick. I mean, if I had to make a quick decision.
Yes,
How would I know
because
how
at
to interpret
night there is no little symbol of I am, no little, you can't see that yellow little reflector.
Yeah.
So yes, at night you want to be very confident in your navigation skills. I would say as a new navigator, you always want to navigate in daylight hours. What is my thing? Slow speeds and daylight hours for new navigators. But you are correct. You could see that, this has a characteristic flashing of 4. This has a characteristic flashing 2 every 6 seconds. So if you have a chart and you can identify the different light characteristic on each buoy, you would know which one to leave to right, which one to leave to left. Yeah, that's my answer for you.
Okay. So basic panic.
Yeah. Okay. Okay. Okay, so this, who was it? Tim, you were doing Mediterranean, right? This is an example of your Ayala B versus Ayala A.
Excellent.
Right here on that page.
Thank you.
Yeah. Okay, let's talk about light characteristics. Our buoys, our lights, all of these things can have different characteristics of the light. This little F or OC, FL, FL2 is going to be what's on the chart and what the indication or what characteristic we're going to see. Again, there's a lot. These are all in the light list and in your chart 1. When it gives you a when it gives you a frequency, like flashing every 2 seconds or flashing every 6 seconds, it's at the beginning of the frequency to the next beginning of the frequency. So this is going to flash 2 and then 1. So let's say you start your seconds or you start your timer here. Let's say that this frequency is happening every 6 seconds. You start your frequency here, and then by the time it starts over again, that's your 6 seconds. Does that make sense when it comes to frequency? So a lot of times you might just have a flashing light, flashing every 5 seconds or flashing every 10 seconds. Every time you see a flash, you could count in your head, 1 Mississippi, 2 Mississippi, to try to figure out, is that a 10-second flash or is that a 5-second flash? Lights that will be close together won't be a 6-second flash and a 5-second flash. Lights that are close together are going to have a larger difference. So that will be easy for you to say, oh, that one's, light so-and-so, and this is light so-and-so.
Is that why they have different flashing patterns just to tell individuals apart, or is there any other reason for?
Yes, to tell lights flashing apart. Let me go back to this one. Sometimes you'll get a quick flashing light. I didn't see it on that. Sometimes you'll get a quick flashing light, like a continuous quick, when there's a change in course in the main shipping channel. Like, pay attention right now, this one is when you're turning. So that's not like a standard rule. I would say that's just common from what I've seen in my experience.
Got it. Thank you.
Yeah. Okay.
Quick question, Captain.
Yes.
On the one before, there's a Morse code. That's the A. Is this the beginning of the harbor? Like when you?
Yes, that's going to be on your safe watermark. Your
Safe
Morse code
watermark.
A.
So that's what that is.
Yep.
Okay.
Yep.
Thanks.
Okay, now we're going to quickly talk about determining the range of a light. So this is also another thing that we see when we look at our light sim or our lights on the charts. It will say, I'm trying to get an example here. Okay. Let me show you real quick. Okay, so this guy right here, we have a light. It's a solid mark with a teardrop. It's flashing red every 4 seconds. So we have a flash, 4 seconds, a flash, 4 seconds, a flash. Its height is going to be 39 feet. And then the range is the nominal range is 5 miles. So we're going to talk about what this and those two things mean to us and how we can apply that to what we're doing on board. So I'm going to be talking about this. So this is going to be height of the light, and this is going to be the nominal range. When I talk about height of the light, here's a light, might look like something like this. The height of the light is to the light itself from that mean high water, the height of the light. So it's not to the top of the building, it's to the light itself. Okay, and then the other thing is nominal range, and we're going to define that. Okay.
As a question, is there a way to tell what the difference is between the current height of the water and the mean height of the water?
If you have a depth sounder on board, you could see what the water under your keel is, apply your draft, see what it is on the chart, and calculate your difference.
Oh, okay.
A lot of times you might, like in Newport, a lot of bridges will have the heights of the water. So even if you don't have a depth sounder or you pass some sort of marker that has depths of water, like bridges or some piers do, you can use that to say, oh, the height of water here is, 12 feet, but the chart says it's 10 feet. I must have a 2-foot tide.
Right.
Something like that. Okay. Talking about the range of light. We have 2 types of ranges. Luminous range and geographic range. The luminous range, well, first, I'll go with this order. Okay, so nominal range is given to you on the chart. The definition of nominal range is how far you can see that light in perfect visibility. Perfect visibility by the Coast Guard standards is going to be 10 nautical miles. So if visibility, if Mark Christie or Dallas Rains tells you visibility is 10 miles, then you should be able to see that light at whatever it tells you on the chart. Maybe it tells you 5 miles. So that's telling you that intensity of the light. Is this light, if it has a 5-mile nominal range, it doesn't, it's not that bright. It has, it's not an LED bright, bold light. It's an incandescent dimmer light. So it's really just telling you the intensity. So your high intensity lights are going to have higher nominal ranges. But then we have to apply our visibility. So whatever visibility is in the area, we can get that from the news, we can get that from the weather report, or you can get it from experience. And, for me, we got visibility a lot with our radar. So if we saw a ship on the radar at 12 miles away and we couldn't see it with our eyes, we would wait for it until we could see it with our eyes and then say, oh, we have a 8-mile visibility. We saw it at 8 miles. We have a 2-mile visibility, whatever it is when you can see that physical thing, that physical thing, that's your visibility. The light cuts through the visibility, right? Like if it is foggy out, foggy or rainy, you're gonna see the cars in front of you or coming at you, you're gonna see their lights before you see the physical car. So visibility is, super dense fog is 50 feet. You're not gonna see that car until it comes within 50 feet of you. But if you have that light on and it's a high visibility LEDs, that nominal range is going to be high. So when you apply your visibility to it, you can see that light further away. Is this making sense? Maybe. Okay.
Yep.
Okay. The second thing we have to think about is our geographic range. And that is between the height of the light and the height of the observer. If I have a light that is, on someone's pier and it's only 5 feet tall and I'm in a kayak, my geographic range isn't going to be that far to that light because of the curvature of the earth. Where if I have a very tall light and I'm on a very tall ship, I'm going to be able to see that light, over the horizon quite a bit and have a further geographic range. So let's look at some pictures of what I'm talking about. Okay, so this is our geographic range picture. Here's our lighthouse, 150 feet above the water line. And we can calculate with the curvature of the earth how far it is to the horizon. So we know that this is our horizon from the light. If I'm on a rowboat, I can only see it 2.6 miles past the horizon. If I'm at a small ship and I have 30-foot height of eye, is what they call it, the height of the eye on the vessel, I can see it another 6.4 miles. If I'm on a large ship with a 70-foot height of eye, I can see it another almost 10 miles. Is that miles? I don't know what that is. Anyways, does that make sense for geographic range?
Yep.
Okay. 2 ways to calculate geographic range is by table or by formula. I'm going to say most of the time you guys are not going to be calculating geographic range, but the formula is out there. The geographic range table is in your light list at the beginning of the light list, as well as your luminous range table. So you have your 2 things, your geographic range and then your luminous range. Your luminous range has those 2 factors, your nominal range, that intensity of the light, and the visibility, how foggy or how clear is it. You use this graph to say, I have a 2-mile visibility, so that's not very much, but my nominal range is 20 feet, or 20 miles, excuse me. So I follow this 20 up to my 2, and I see that I'll be able to see it at 6 nautical miles. If I have a 2 nautical mile visibility, really foggy, but that light in perfect weather can shine 20 miles away, I will be able to see it at 6 nautical miles. That's how the luminous range graph works. So when you are looking at it, you're applying these 2 things, height of eye, height of light, nominal range, and visibility. Whichever one is smaller, your limiting factor, if you will, whichever one is smaller is going to be your visibility of the light. So even if you can see that light at 6 nautical miles, but it's really low and you're really low, geographically, you won't be able to see it until what your geographic light is, whatever range you calculate. So whichever is smaller, your geographic range or your luminous range, whichever one is smaller is going to be the visibility of your light. And that's where we use those last 2 numbers on the chart. Wow, I even do an example of this? Okay.
So
Yeah?
the 5M is the strength of the light.
Yes. Yes. So that's saying, okay, so here's an example. This is one of the brightest lights on the west coast of the Americas. Mazatlan. The light in Mazatlan has a range of 33 miles. So in that perfect visibility, 10 miles, it can shine through at 33 nautical miles. It's also telling us the height of the light is 515 feet. This is way up on top of the cliff. So height of the light is 515 feet. Nominal range is 33 nautical miles. I'm just giving your visibility is 8 and your height of eye is 20. So if we were to calculate this out, our geographic range, we should be able to see the light physically at 31.7 nautical miles. So I should be able to see that light physically, the edge of that cliff, at 31 nautical miles. With the luminous range, having visibility of 5.5, pretty foggy, and a nominal range of 33, my luminous range is only 20 nautical miles. So the visibility of the light is 20 nautical miles. But again, this is mostly for those of you who are doing 100-ton tests. I would say for the everyday recreational boater, you are not calculating visibility. Okay, any big questions so far? No?
With perfect visibility, you know, blue skies. You said the range is 10 miles.
That's what the Coast Guard defines perfect visibility.
You can see 10 miles.
Yeah. So when you look up, yeah, the definition of nominal range, it's visibility of the light at 10 miles.
With the human eye.
With the human eye. All right, well, let's take a 10-minute break and come back at 8:10. And let's come back with our 1210 charts set up. We're gonna dive into plotting lat and long and plotting course and distance. So I know I just talked a lot about aids to navigation, but we kind of don't talk about a lot about aids to navigation from here on out. And from here on out, we're doing a lot of plotting. So if you come up with an aid to navigation question, please let me know and I'd be happy to talk about it. But yeah, we're gonna move into plotting tools. So let's come back in 10 minutes.
Bree, you know, one thing I don't get is how to log on to the Google Classroom. How do you do that?
Yeah. Can you hear me now?
Yes, now I can.
Okay.
Yeah.
Yes. So do you have a Google account?
Yeah, I mean, I have Gmail. I almost never use it. I mostly use Outlook, but I do have a Gmail account.
So you're going to want to, let me open a new incognito window. Okay, let's see. Share my screen here. Okay, so I opened a new window. We'll just go to Google.
Uh-huh.
So you want to sign into Google with, you could either, you know, create just a temporary one right now, just a random one, or an old one that you have. Somehow sign into Google.
Uh-huh.
And then you can go to the app section here.
Right.
And you have all of Google's apps. And you're going to go to Classroom, which I have not seen. So I'm going to do more from Google. You could just type in Google Classroom.
Uh-huh.
And it would come up.
Classrooms.google.com.
Okay. Yeah, why? Google.
So it's classroom. It's classroom.google.com. Oh, I see.
Classroom.google.com.
Okay. And then we type in the code that you gave us, and then we're in. And
yep. So there'd be a little plus sign. So I'll go to mine here. Oops. Shoot.
But you got to sign in with your Gmail account.
Correct.
Okay.
You're gonna pick the one. It probably will tell you which one you have.
So if you click on the link in the chat box, did anybody try that?
Yeah, it worked.
That worked? Okay, so you can just click on the link. So yeah, I go to Classroom.
Oh, okay. Mm-hmm.
and then my classes come up. But the little plus sign here, join a class. And then you could put in your code.
Okay. So you go to classroom.google.com and then join a class and then enter the code.
Yes, but try just clicking the link in the chat.
Well, where is that link?
In the chat on the bottom?
So on the bottom, are you on an iPad or computer?
I'm on a PC.
On a PC, okay. So if you put your mouse towards the bottom of your Zoom screen,
Mm-hmm.
you'll see chat.
Right.
So you click on that,
Right.
and then
Oh, I see.
Google Classroom, I put up a link there.
Okay.
Try that.
And Bree, do we get to keep all this, or you said it was temporary?
So you can download everything and keep it. That's fine. I won't take you guys off of the Google Classroom until I have a next CoNav1 class, which will be in January.
Right. So, but if I wanted to refer back to this, I have to I have to save it.
Yes. Yes. You could save it to, your Google Drive or something. And you can always email me at any point and I can send you some stuff. But I do take the
That's the
old
first time
student.
I've ever used the classroom.
Okay.
It's interesting.
I don't use it like I think it's designed for. Like I don't have assignments or things referenced, but I don't know. It's a place that I can post things.
Captain,
Yes.
when is the next celestial navigation course? Are you giving that anytime soon?
So we do that actually only once a year, and we just finished it.
Oh,
So it usually starts right after July 4th. So
it's not the same, is it, in over Zoom, because you kind of like have to look at the stars and it's
so this time we did it over Zoom. We did all of our lectures over Zoom, and then we did our in-person. We did 2 sun noon fix and then a star sunset fix on the Newport Pier, in person, masks, socially distant,
cool.
all that. But we did no in classroom, like we were never in a room together.
Right.
So we'll see how next year goes. Who knows? All right. Are we ready to get started?
Yes, please.
All right. Hold on. Let's bring it up. All right, we got the PowerPoint, right? So we're going to talk about measuring latitude and longitude. We're going to talk about measuring these things, and then I'm going to do a demonstration with the document camera here on each set of tools itself. But I just wanted to get through the PowerPoint so that I could switch to the document camera. Okay, so when we're measuring latitude and longitude, and in this situation, I am just going to be measuring the latitude and longitude of this buoy here. So you can either have latitude and longitude, like from your GPS, that you want to plot your position on the chart, or you want to find what the position of an aid to navigation or an entrance to a harbor or whatever it is. this example, we're finding the latitude and longitude of this buoy. So the concept we're going to use, or when we're looking at our chart, we have our latitude lines go horizontally, and we measure them on the far right or far left side of the chart. Our longitude line goes vertically, and we measure it on the bottom or the top of the chart. Every 10 minutes of latitude and longitude, there'll be a bold black line, or just a black line on the chart through that entire longitude and that entire latitude. So we want to find the closest black line to the object in question. So the concept we're going to use here is, if I wanted to measure a straight line on the ceiling to hang a picture, or I wanted to parallel a line on the fence, or whatever it is, a easy way to do that is to draw from one known line that you want to parallel down a certain distance. Let's call it 12 inches. And 12 inches, and 12 inches. If you put a mark 12 inches all the way across and you connect all of those dots, you would get a parallel line to the line that you measured from, right? Can everyone kind of remember that? So just using that concept, we're going to transfer that concept to our latitude and longitude. So if I measure the same distance from this line to this buoy, this line to this buoy. Oh, and we want to, so the buoy, we want to measure what it is all the way to the right or left side of the chart and all the way to the bottom or the top of the chart, so we can read what the latitude and longitude is. But sometimes, most of the time, our ruler, our triangle, our whatever we're using won't reach all the way perfectly. So we can reach it to the nearest bold black line, and that can be our indicator of where it will be on the bottom or the side of the chart. So if I measure the distance between the bold black line and the buoy here, it will be the same all the way across. If I measure the distance between the buoy and the bold black line for longitude, it will be the same all the way to the bottom. So how I like to draw a latitude and longitude is by drawing a perpendicular line to the latitude and a perpendicular line to the longitude, so I can easily measure this distance and this distance. So that's how I quickly measure latitude and longitude. Another way to draw in a perpendicular line is to use a tangent arc. The tangent arc means that if you draw a circle using a compass, so I'm going to talk about it in a minute, but your dividers have two pointy ends where your compass has one pencil end and one pointy end. And if you draw a tangent line, meaning that arc only crosses a line in one position, that would be a perpendicular line. We'll go into that in a little bit. Okay, creating streets or courses. So we want to, right, there's no streets or known paths on our chart. We can literally navigate wherever we want, but we want to plot a course that can be what we're aiming to stay on, the shortest distance from point A to point B. If I want to go from this harbor to this harbor, or I know I'm here and I want to make the approach to this buoy or something. I want to go from point A to point B. If I draw a straight line, that is going to be the closest possible, the shortest possible distance, right? So if I draw that straight line, it doesn't mean that I can go on that line. As soon as I draw a track or a line from point A to point B, I want to check that path for hazards. I want to look, am I crossing a traffic lane? Am I crossing a shoal? Am I crossing land? What is going to be happening if I stay on this track? Do I need to, you know, dogleg west and then go north, or whatever I need to do? That we always want to check that path for hazards. A lot of times in recreational boating, we're going to be going from one buoy to another. And that's because it's easier to steer at something that you see in the horizon or in the distance. If you see that buoy or that point of land, it's easier to steer on that point of land than it is on your compass, on your number that you could be kind of swerving. It's pacing the compass back and forth, and you kind of get one of these motions going. So to have a steady course, common practice, unless you have an autopilot or something, which a lot of people do. Excuse me. You want to aim for a buoy. So a lot of times our courses or our track lines are from buoy to buoy. Again, in big boating, I do not like going from buoy to buoy. That is not safe in my mind, but I know that's how we do it in recreational boating. So moving on here, all of the courses that we draw on our chart are going to be read as true course. A lot of times on our boat, we are steering by magnetic compass. Next week, I'm pretty sure it's week 3, we talk about the different compasses, true, magnetic, compass, and compass error. So I'm not going to get into that this week, but everything on the chart is true. So if we read a course on the chart, we know that it's true. Okay, so this is going to be my graphic, but I will show you on the chart myself of using a roll plotter. So the roll plotter, you line up with the line in question. So you drew a straight line from point A to point B. You checked it for hazards. There's no hazards along the way. We are good to go. What course is that? So I'm going to measure the edge of my roll plotter, line it up with the line that I just drew, and then I'm going to roll it up to the compass rose. That's going to be our compass rose. And if we can remember from last week, the outer circle, that one with the big red star, is true. So we are going to measure the true compass. So there it goes. It slid right up to our compass rose. And now we can measure the course. If we have parallel rulers, same type of concept. We're lining up the parallel rulers along the line, and then we're paralleling them up to the compass rose. Again, I will show this to you on the chart.
I can use a long straight edge to slide the plotter over. Was that kind of work the same?
What kind of plotter are you talking about?
So if I've got this on the chart, right, but I can't get to a compass rose for where it is on my chart, am I able to slide this?
Yes.
Okay.
Yes, you are. Yes. And I will show you some of those tips and tricks on the chart. Okay, then third tool we have is the triangle. Once you learn how to use the triangle, you'll never go back to anything else. To me, they are the easiest and most accurate. I know they are hard to wrap your head around at the beginning, so a lot of people prefer the roll plotter or the parallel rulers. But for the triangle, you don't have to use the compass rose. You can notice on this, I have no compass rose. All you have to have is a vertical line. So every 10 degrees of longitude, there is a vertical line. So if your course crosses a vertical line every 10 degrees, which most likely it will, sometimes it won't, and if it doesn't, the movement that it takes to move a triangle is a lot less than sometimes it takes to move to a compass rose, where you're going halfway across the chart. Okay, so to read a triangle without using a compass rose, you measure the focal point of so you put the long side of the triangle. So we have a long side of the triangle and two short sides. The long side of the triangle goes along the course line, or whatever line that you're measuring. The focal point, there's a dot on the triangle, but where all the lines come together, that goes on a vertical line. So that crosses a vertical line, and wherever that vertical line crosses the edge of the triangle on the bottom side, that is how you read it. That 065 would be in this direction, and 245 would be in that direction. So there was no movement involved in this. It's just put it on the chart and read it, which can be helpful if you are on a rocking boat. So that's triangle uses. Again, I will show it to you on the document camera. Measuring distance. Measuring distance, excuse me, we always measure distance using latitude, meaning the right side or the left side of the chart, not the top and the bottom. Because 1 minute of latitude is equal to 1 nautical mile. 1 minute of latitude equal to 1 nautical mile. So if we measure from point A to point B, just by using our dividers or our compass, and we can move that to the side of the chart, the right side or the left side, and measure how many minutes of latitude it is, and that will equal the nautical miles. If you're, a lot of you, I would say most of you have dividers that look like this. They have like stopper on the sides, so it only goes a certain distance and it stops. So if your distance that you're measuring is further than that, then we're gonna what we call walk the compass. So I would have a known distance. Commonly I use 5, because this goes, I think, to about like 7.5 maybe. So I'd use 5 nautical miles, and then I'd walk it. I'd go 5, 5, and then what's my remainder? I'd measure that, bring it back to the side of the chart, see what it is, 2.3. So then I could say this whole distance is 12.3. Okay, now we're going to go to our demonstrations. Any big questions so far? Okay.
See on my thing, it says nautical miles. So put this there, it's 5 nautical miles. This is 5 nautical miles.
Yes, so on your triangle, let me try to call this.
It's on the long side.
So some have it and some don't. Depends on what triangle you have. But if you could also see, oh, let me get a piece of paper. That scale, that nautical mile on your triangle will only work on a chart that is a scale of 1 to 80,000. So if you are zoomed in or zoomed out, it would not work. For both charts that we're using in our class, it will work.
Okay, good.
But it won't work on every single chart you'll ever see if you're zoomed in or zoomed out one way or the other. So to keep in mind, if you have a distance scale on, you know, this roll plotter has it for 1 in 80,000 and 1 to 40,000. So you always want to note the scale that you are working with if you're going to use this as a distance measuring. Let me bring this up real quick.
But most maps you say are 1 and 80,000. Most charts.
I would say the majority that you will work with. But as you get closer to shore, you're going to want something, you know, zoomed in, something larger scale. Because I wouldn't want to navigate, you know, Long Beach Harbor or Newport Harbor on that 1 to 80,000 chart that we're working with. I want something a little more detailed as I get closer to shore. And then if I'm plotting, you know, a Channel Island cruise, I want something that covers more of the Channel Islands or something like that.
So, I'm sorry, is there a way to use this thing on the actual chart? To say, this is to find my 5 nautical miles?
Yes. And I am going to show that to you right now. Okay. Bear with me. There we go. We got bottom and the top. Okay. So I am going to draw a line. Whoa, it fell. Okay. Sorry, I'm having difficulties with this. Okay.
I feel like I'm on a boat.
I know, it won't stay. Okay. Keeps falling. Okay, that will have to work. Kind of focused. Okay, can you still hear me?
Yeah.
I'm going to draw a line from this buoy to this buoy. So I'm just going to draw a straight line using a ruler. You don't have to have a ruler, but I'm just drawing a line. So I want to measure this course of what I would go if I was going from this one to that one. I would say the most common tool is going to be your roll plotter. So when using a roll plotter or any of these tools, I like to measure on the black line that is parallel to the edge. You can totally use the edge if you want. Sometimes if your tools have been around the block, bumped around, you don't exactly have a straight line. And depending on the thickness of your tool, the parallel rulers are much thicker. You can have like a little bit of reflection, whatever it is. Again, these are like super minor things that don't really matter to you as a recreational boater, but I like to just start with some good habits, and then you can find your little shortcuts along the way. So I'm going to measure my black line on the line that I just drew. So I know it's hard to see that, but my black line is on the line that I just drew. And to use the parallel ruler, you're going to push down on the middle part. So just not on one side, not on the other, just right in the middle, a little bit of pressure. And then you can roll this roll plotter towards a compass rose. So I'm going to roll it towards the compass rose. I'm going to put my pencil on the center of the compass rose, roll it till it hits my pencil, and draw a line. And then I can read. My course that I drew right there was about 037. We'll call it 037. So that is how you use the parallel or the roll plotter. The trick is sometimes you don't have it right, the compass rose right on path. That maybe you paralleling something like this and you just miss the center of the compass rose. You always have to start from the center and draw your way out of the compass rose. So if you just miss it, then you can get another tool, parallel it down, parallel it back, and each time you move it, you have more likelihood that you're going to jiggle it one way or another. And we are all going to be jiggling our nav tools tonight. It is a practice that takes training and time to be smooth with your nav tools, no matter what nav tools you use. So don't get, or try not to get too frustrated with yourself if you've worked your way all the way to the compass rose and then at the very end you jiggle and then you have to go back again and then you get there and then you go back again and then you get there. That will happen a lot. I'm just throwing it out there. So I like the roll plotter because it's very intuitive, that you line up the line and then you bring it straight to the compass rose and you can read the line. Very intuitive that way. The only problem comes when you miss the compass rose and you're on a chart that doesn't have a lot of compass roses, so you're figuring out all these other ways to get to the compass rose. Again, you can just use a straight edge, but I guess those are my pros and cons for the roll plotter. The next tool is the parallel rulers. So these are rulers that parallel one another with these little hinge on it. Again, you can get these without the black lines on them, or you could get them with the lines. I prefer with the lines because that's how I like to line things up. But whatever you have, use whatever you have. So I'm going to line it up, the black line right on the line that I have in question. And then with the parallel rulers, you kind of do this dance with your hands. So I want to keep one ruler still. So I put pressure down on one ruler. Then I can move the other ruler. Oops, see, I jiggled. I can move the other ruler freely. I'm going to line it up on the other one. less movement. So I'm putting pressure on this one. Then I can move this one freely without, if I'm keeping pressure on this ruler. So I'm going to move it as far away as I can. And then I'm going to put pressure on this ruler and release pressure from this one. So then I can close it back up and then put pressure on this one and move it over. Dang it. My camera is stopping me from moving it. So now I'm going to move my camera. Having camera trouble today. Oops, I jiggled. Let's pretend I didn't. And then you're going to move it to the center of the compass and draw a line. As you can tell, I do not use parallel rulers. I'm not as comfortable with them. I jiggled a lot. Don't worry, you guys are going to jiggle too, but the more you do it, the more comfortable you'll be. So things I like about the parallel rulers, they are intuitive when you're walking them, but the things I don't like is that when you walk, you have more chance of jiggle, and it kind of takes this dance or this coordination with your hands. Again, not impossible, you just have to get used to it. A lot of times I do see with measuring latitude and longitude. So here's a longitude line. If I wanted to get the longitude of this, the parallel rulers are so long that I feel like I've seen it as easier for people to use them to get your latitude. That in this case, my latitude for finding my longitude here took very little movement. So I'm going to go over latitude in a second. So, or positioning in a second. So that is the parallel rulers. Okay, lastly, we have the triangle. So if I did it this way, I was running off of the chart here. So I'm going to do it this way. Doesn't matter either way. So I put the long side of the triangle. This is the long side. These are the short sides on the line in question. And then I put the focal point on a vertical line. And then I read, I know you guys can't read, but I read the course direction on here. So on this one, I have 038. So the pro I like for the triangles is that you don't have to move them 70% of the time. I'm not going to say you never have to move them, because sometimes you do. Especially if a line is close to vertical, then you'd probably have to move it. But 70% of the time, you don't have to move it. And the, you can tell, the distance between each little degree is much bigger than the distance between the degrees on the compass rose. So I find it easier to read than the compass rose sometimes, because they are, and we will experience this in our homework, very close together. So I just find these spread out more, easier to read. Okay. So that is course. What was the question?
Just really quickly, I'm noticing on the triangle, as the last question was answered, the 1 to 80,000, are the other scales only in 40,000 and 20,000? Or are there other scales?
There are lots and lots of scales.
Because my question is more of, does it make sense to just multiply by 2? to get from 80,000 to 40,000, multiply by 4 to get to 20,000?
Yes, you can. If you look at the top of the chart, do you remember where the little key is for all of the other charts if you wanted to go to larger scales?
Yep.
You can see you have 1 to 15, 1 to 20, 1 to 40, 1 to 10, 1 to 15. So there's lots of different scales that you could be on.
Okay. Yeah, it just seems like pretty simple math there. Save a little bit of time.
Yes, you can. And whatever is easiest for you, everybody's brain works differently. So for distance, I teach the way of just measuring from point A to point B. So you just use your dividers or your compass. This one, I have a compass point. I just don't know where my dividers went at the moment. So I'm using this one. And then you just bring it over to the side. I'm going to start here at 41 degrees 10. And then I have 1, 2, 3, 4.5. So my distance there would be 4.5. As some of you have mentioned, you can use the scale if you have 1 to 80,000 and you are on a 1 to 80,000 chart. You can use that scale and get 4.5. This guy has a scale as well to get 4.5. So whatever you find easiest to use. So
that guy got 1 to 80, 140, 1 to 20.
Okay. So you have, different options.
4.5 nautical miles. Correct?
Correct.
Question, Captain.
Yes.
The point where you take the measurement on the buoy, is it the pointy? The buoy is like a balloon.
Yes.
Point. Is that the beginning or the end of the measurement? Because that's like 1/8 of an inch.
So the circle is where the buoy is. The little diamond can be anywhere. It doesn't, the direction of it doesn't have a significance, and the size of it doesn't have a significance. What you're looking for is that open circle.
Okay, thanks.
Yep. Okay, so.
And you wouldn't have to start at 41 degrees. You could do that at any of those degree lines, right? To measure the nautical mile distance.
Correct. You can measure it from the 15. You can measure it from the 12.
Okay.
I guess I tend to go on the 10 or the 20 or the 30, just so the numbers start at 0 for me. But it does not matter. You're just measuring that distance. Okay, so now we're going to talk about latitude and longitude. So we're going to plot. Let's come up with a new spot. Actually, you guys are following along with me. Okay. Let's plot this buoy. We're going to plot buoy 1. So what I like to do, my quick way of doing it, is to draw a perpendicular line to the nearest bold lines. So I have a bold longitude line here, a bold longitude line here. I have a bold latitude line here, and a bold latitude line here. So how on the triangle, because you have these perpendicular lines, I put my pencil on the buoy in question or the position in question, and then I line up a perpendicular line. So the center of the triangle, I line up on a vertical. And then I draw a line. I do the same thing, put my pencil on the buoy, and put that perpendicular line along this latitude line, and then I draw a line. So I have these two lines to my buoy in question, and then I use my dividers, and I go from the buoy directly to the line where it crosses the buoy, and then I parallel it over, and I can read that my latitude would be 15, so 41 degrees, 15.56, we'll call it 15.7 or 15.6, no, 7 or 8. Let's see. Call it 15.7. So you just moved it over. For longitude, oops, and you bring it down and you read what it says. We have 45, 46, 46.3. So that's how I would do it with the triangle. I do triangle and dividers. If I have a roll plotter, I line up a latitude line. So if I line up a latitude line and it crosses the edge, that's great. I don't have to move anything. But if I line up a latitude line on the latitude line, and then I'm going to parallel it down to my buoy, and I can draw a line all the way across or just draw a line of where it would pass my the edge of the chart. Same for longitude. I line up my vertical line with my roll plotter, bring it over to the line in question, and so I'm bringing it down to the line. I can do it over again so it passes the actual indication down here at the bottom of the chart. So that's a little bit easier. If your position that you're trying to find is in the middle of the chart, you do that same thing, but just to a bold black line, just like what I did there. And then you could measure that all the way down. With the roll or parallel rulers, same type of thing. You put the black line on a bold latitude or longitude and bring it over to the buoy in question. Put this guy on the latitude, line it up, and parallel down to measure your latitude. So I would say the roll plotter and the parallel rulers are great for latitude and longitude closer to the edge of the chart, but you will still have to do the whole divider, walk your way over if you are closer to the center of the chart.
Do you use your roll plotter to go to the side of the chart to get if you're in the center of the map or the chart, excuse me?
So your parallel roll plotter doesn't go up or down. It just goes one way. So say you were, I guess we have the star here. I'm trying to find where it crosses a longitude. And so if I just keep rolling, it's only going to pass the latitude line. So you would mark where the star is crossing a, the bold latitude lines, and then you could get that distance and bring it down to see the same distance at the bottom.
Okay.
Or at the top. I think this will make more sense as we do it together. So we have a half hour left. Let's do the first 2 questions on both assignments, if that's okay. Any questions so far before we dive into the homework?
Yes, quick question, Captain.
Yes.
Reading the, so it's 41 degrees. That's the whole thing. It's 41 degrees, and then it's divided into tens, right?
Yes. I didn't go into that. You're right.
Oh, then am I ahead of myself?
No, I skipped over it. I apologize.
That's okay.
So you're right. It was
no, go ahead,
41 degrees, 15.7 minutes north. And then I had 070 degrees, 46.2 minutes west.
Okay. Thanks.
You're right. Okay. So for assignment 3, this is also an exercise in familiarization of where these places are. Because most of us in this class are not East Coast boaters and know all of this East Coast chart. So it is an exercise of where all of these little places are. If you get really stuck, I would look at the answer sheet to just ballpark where you think it is, just to help you find it, and then practice your latitude and longitude. Okay, so assignment 3 is finding latitude and longitude of these specific points: towers, lights, buoys, monument, etc. And then assignment 4 is going to be plotting the course and distance from lights and buoys in different places along the way. So let's get started. We're going to start with number 1 on assignment 3.
You said there were answers? The answers were somewhere?
The answers are on the Google Classroom.
Oh, okay.
If you can't find them there, or if you can't get onto the Google Classroom, I can email you the answers, but they are on the Google Classroom. Okay, so I'm going to do the first one using the triangle and the second one using the roll plotter for both of these questions. Okay. Okay, so Point Judith for number 1, we're looking at Point Judith Light. So Point Judith Light, remember our light is a solid with a teardrop. Our buoy, number 3 is going to be a buoy. That's going to be an open circle with a diamond. So we're using our, is this a light or a diamond? Or a light or a buoy reference here. So Point Judith Light we are looking at this light right here. Point Judith light. We can check the, what do we have? A group occulting, 1 + 2, 15 seconds, 65 feet, nominal range, 16 miles. It has a horn. So we can say this was the correct light. I'm going to measure the latitude and longitude. So again, for number 1, I'm just going to do the triangle. For number 2, I'll do the roll plotter. So I put my pencil on the light in question. I make a parallel, a perpendicular line, and then I draw a line across. So I can read this. Here's 20. So we have 41 degrees, 21. So here is 21. Here is 22, 23, 24, 25. Oh, you can't see that. Okay. So here's 21 and here's 22. So this would be 21.5. And I would call this 6, 7. I would say 21.7 minutes north. That's going to be my latitude. For longitude, I'll put my pencil on the buoy, bump up my line, draw a longitude line, and then I'm going to use my dividers or my compass. Yeah, I'm going to get a divider. So
You bumped up your line to 30?
I bumped up my line to
Your vertical line?
my vertical line. I did it to the 20 degree there.
Okay, you went down.
I went down.
Okay. And you're
Okay,
putting it right in the eye of that triangle, or you're just putting it the edge right through it of your lighthouse?
Using the triangle, I
Yes.
put my pencil on the lighthouse,
Okay.
and then I put that eye and that 90-degree east line on the longitude line, or on that latitude line.
Okay. Gotcha.
Because this is crooked, it's hard to look. There we go. Trying to get, there it is. So I drew a vertical line. So now I see where it crosses that distance. So a lot of times people will just say, oh, well, I can like eyeball that. Why do I need to draw a line? Yes, you can definitely eyeball it. Again, eyeballing it just is a shortcut. So I'm saying you can do that. When you are working on a Coast Guard test or something with this Loran Sea overlay, your mind plays tricks with you, and a straight line turns not to a straight line with all of these other lines crossing it. And sometimes you're like, okay, this is the most closest way to get to this line, and it can be very off. And then when you get to your measurement, you can be closer or farther away. So I just like to say it's a good habit to get into of drawing that perpendicular line. Okay, so I have my distance. I go all the way down to the bottom. And I have 7130. So this is 25, 26, 27, 28, 29. So I'm at 28.9. So I'm at 071 degrees, 28.9 minutes west. Excuse me. So that's going to be my Point Judith light position. Any questions on how I did that one? Okay, now
Read
I'm
through it
gonna,
again.
Bree, quick question. So basically, if you were trying to use parallel rulers, then for the longitude, you're telling me that you're really not sure if you have a straight line.
no, if you're using parallel rulers,
Yep.
you're lining up your straight line with that longitude line,
Understand.
right?
Yep.
And then if you bring it over to the light, you can draw a line to the nearest bold line, or you could go all the way down to the bottom because your parallel rulers are so long.
Yep.
That you can just read it directly off the bottom.
Okay. Thank you.
Okay. Breton Reef Light. Moving a little bit further north here. This is going to be our Breton Reef Light. So it is a light. It has a solid dot with a circle on it. So again, I like to, oh, right. I'm using the parallels. I'm using the roll plotter this time. Okay, so for latitude, try to get this all on the screen here. Okay, so for latitude, I'm going to parallel my latitude line. So I'm using that 41 20-minute line. I'm going to push my pressure right in the middle and roll all the way up until I hit the light. So I like to put my pencil on it. That way I actually have something I can bump into. And then I can draw a line all the way across if I want, that this is a parallel latitude line. So that line is my latitude. And now I could read it. This is 25. So I have 25. This is 26. So I'm at 25.6. So I'm at 41 degrees, 25.6 minutes north for my latitude. For my longitude, I'm going to draw, not going to be able to reach, so I'm going to parallel this line of longitude. This is 7120. I'm just going to parallel this longitude line right over to Breton Reef Light, and then I'm going to draw in that longitude line. So for this one, it doesn't reach all the way down or all the way to the top of the chart. So I just went to the nearest bold line. And now I can measure the distance from this longitude to the longitude of my buoy is this distance. So if I bring that all the way down, I would get 20, 21, 22, 23, 24. So I would get 23.4. So 0, 7, 1, 23.4 minutes west. So even though I did my roll plotter, I still had to use the dividers to get down to an edge.
I'm getting some water.
How'd you guys do on that one?
At 23.3, but pretty close.
Okay.
Pretty good.
All right. Good, good. Okay. Now I'm going to go to assignment number 4. We need another minute. I'll give you guys another minute.
What was the answer to the Breton Reef longitude?
Longitude 07123.4.
Because that's your big.
Captain, under assignment 4 on the course, which plotting tool are you going to use first?
I'm going to use the triangle first and then the roll plotter.
Thank you.
This isn't super zoomed in.
But if anybody wants me to do it again in the tool that they're using, holler at me.
So these are.
Can you do the triangle slowly for Judith Lighthouse again? Point Judith, I'm struggling with understanding how to make sure the lines are perpendicular.
Okay. Okay, so our triangle has this perpendicular angle, right? If this line, this side of the triangle is going to be perpendicular to this line that goes through the triangle.
Copy that.
If I line up this middle line, anything on this side would be perpendicular to it. So I'm going to line up this vertical line on a vertical longitude line. So if I keep that on the line, anywhere I move this is going to be a parallel, an exact longitude line as I move it. So I'm going to put my pencil on Point Judith, and I'm going to line up keeping this line, so that center of the that center dot, if you will, on the vertical line.
Yeah.
And that whole 90-degree angle on that vertical line. And then I could draw a line all the way across.
Okay, I got that one.
Okay, so that's going to be your latitude line that you just paralleled.
All right, give me the longitude line, please.
Longitude line. Again, I put my, here, I'll do it this way so you can see. So this, perpendicular line is going to line up on your latitude line now. So anything that you draw right here is vertical, is pointing due north or pointing due south, because it's lined up on a latitude line. It's perpendicular.
Got
So
it.
I'm going to put my pencil on Point Judith, light, and then I'm going to bump up my triangle and adjust it. See how I can move it one way or the other?
Yeah.
Adjust it so this vertical or this perpendicular line is right on the latitude line.
Okay.
And then I could draw in my longitude.
How far down do I draw it to?
To the nearest bold line.
Copy that. Okay. Now, so I do that, and now I extend it. So then make sure it's parallel.
Okay, so let's see. Okay, so I'm going to jump to assignment number 4.
Thank you for that.
Yep. Assignment number 4, number 1. We are going from buoy 2, that's going to be this buoy right here, to Breton Reef light. So this light up here. Excuse me. So I can check the characteristics. This is buoy 2, flashing 10 seconds, has a whistle. Told me if it was off Point Judith, okay. Breton Reef light, we already identified that one, gave us again. What is the course and distance? So step 1 is to draw a line. So we're just going to draw a line from one dot to the other. Yeah, just draw a line. I overshot my line. It doesn't matter. However neat you want to be is fine. Me overshooting the line will make it easier for me using my triangle, but I'm going to do it 2 ways. So if you are doing this on a roll plotter, your compass rose is right here. I'm going to do it on the triangle. So let's see if I can move it a little bit like this. So I'm going to line up the long side of the triangle. So this line, I'm going to put this line on my line in question. Then I'm going to put this focal point on the vertical longitude line. So here's my line that I'm looking at. So I'm going to line up that line, and then I'm going to put this focal point right on that vertical line. And then on the bottom here, this is where that vertical line passes through my my course. So if I'm going from this point to this point, my course would be 035.
This is a mess.
Okay. If I just went from buoy to buoy and I didn't overextend my line like I did, or buoy to light, excuse me, and I didn't overextend my line, my focal point there is not on a vertical edge, right? So I have a vertical edge here and a vertical edge here that I need to move it to. So I would say this focal point, just moved it, is a little bit closer to this vertical edge. So the shorter distance, the less likelihood of jiggling. So how to move the triangle, I guess we didn't go over that. How to move the triangle to a vertical, if it's not crossing a vertical, you move it using the short sides of the triangle. So I'm going to put a straight edge. Could be a ruler, could be another triangle. A lot of times they sell triangles in pairs. It could be the side of your divider box. Could be any sort of straight edge. I'm going to use a ruler here. So I line up my line on the big long line, and then I use a straight edge to bring it over to the vertical line. So this distance from here to here, to me, is shorter than bringing it all the way down to the compass rose. But again, this is the one I prefer, but I know you guys don't use it this way. Okay, let me show you with the, I'll do it both here. With the roll plotter, you line up the line right on there and just roll it on down to the roll plotter, draw in your line, and then you can read it, 035.
Minutes are 1 nautical mile.
Yeah. What does 035 mean?
That is a course. So on our compass rose here, north is 0, east is 090, so that's 90 degrees from north. South is 180, west is 270. So I had a course of 035. So that means from due north, I am 300, no, 35 degrees clockwise from due north. So everything starts at 0 on our north, and then we go 90, 180, 270, 360.
Question, Captain.
Yeah.
And from your experience, what's an acceptable margin of error? I mean, what does that translate to when you're actually?
Yes. So the more accurate you can be, the better. I would say for this class, if you are in, I want to say 5 degrees, that's pretty good. The 5 degrees here is just so small that it's very easy to be one way or the other. 5 degrees is a lot though. And if you're navigating a short distance like this from point A to point B, 5 degrees, give or take, might get you this far off course. If you are navigating 5 degrees off course for a long distance, you are going to be very far off course the further you go. Does that make sense?
Yeah.
So for short distances, you can be less accurate. For longer distance,
Sure.
You want to keep checking. Check every hour, check every 2 hours, whatever it is to make sure you are on the right heading to maintain that course.
And that comes later in the class where you have to figure out your position and then reassess where you're going.
Yes.
Okay.
Yes. We're just learning our basic skills right now.
So
nav tool skills. Yeah.
So the 035 is on a compass.
Yes.
You keep the compass on that line.
Correct.
Got it.
You want 035 on your compass. You keep it at 035. You'll be moving along this line. Okay.
Doing this with the triangle, I was able to do it without extending the course with one triangle. Can we just slide along it as long as we're keeping the flat edge like flush with the line?
Yes. Yes.
Okay.
Yes, yes. Okay, quickly before we run out of time, I'm gonna do number 2. Is where is it? We're doing Breton Reef. Oh, we're doing a little one. I remember this. To buoy 11, which is, what did I say? Buoy 11 is near Bull Point. Bull Point is up here. So buoy 11 is going to be this red one. So we're at Breton Reef and we're coming up into Narragansett Bay. So we're going to go past Bull Point. Oops. Sorry. I didn't know I was off the screen here. Okay. So here's Breton Reef and we're coming up into Narragansett Bay up here. And we're going to go past Bull Point, which is right here. The buoy 11 is this buoy. And we are going to go straight to buoy 11. I didn't emphasize this the first time, but every time you draw a line, you check that line for hazards. I forgot to do it on this one. This line, we are crossing land. We cannot do this, right?
Right.
Everyone see that? So it asks me what's the coursing distance, but then it also asks that we cannot do this. Is this okay or not? We cannot steer this as a straight line because we are going to run into land. We would need to steer closer to the left and then turn to the right, kind of a little dog leg. But to get our answer, we're going to measure this line. So I'm going to start with the roll plotter this time. I'm going to put my black line on the line in question. And then I'm going to bring it down to this compass rose. So I'm going to bring it down to this compass rose. And I get 0 to 8. Again, I kind of knew where my compass rose was, so I lined it up pretty low. If you center it up, which is a natural thing to do, on the point in question, you might miss the center of the compass rose. So then you might have to parallel yourself down and find it again. Remember, always keeping pressure in the middle of this metal bar to keep it steady. Distance, oops, I forgot to do distance on the other one. You guys gotta keep me on my toes. Distance for this one.
I was on mute. I tried.
Ah!
0.8.
Distance on this one. You just from point A to point B. I get the dividers. And then I bring the dividers over to the side of the chart. I'm just going to do it here because you can see it. So 20. This is 1, 2, 3. 3.2. 3.1, 3.2. I would say on nautical miles and latitude and longitude, I would try to be within 0.2 of either nautical miles or latitude and longitude. And then for course, let's try to aim for plus or minus 3 degrees instead of 5.
So
sharpen our skills.
Can you confirm the distance again? I got 3.7.
Yeah, I have 3.7 as well.
Yeah, I 3.7.
You're right.
3.7.
3.7.
3.8.
But I can use this too, right?
Yes. Yes.
This has mileage.
Yep. You can use that.
Captain, what did you get for the course?
For the course, I got 0 to 8 degrees true.
So when they write the abbreviation for nautical miles, do they use a lowercase n and m or uppercase n and m?
You can use either. A common practice in logbook writing is to write everything in all caps.
Okay.
So I don't know. I tend to write nautical miles in lowercase.
Yeah. Mm-hmm.
But doesn't really matter.
Okay.
Hey, you have a T next to it?
Yes, that is true. Because all of anything that comes off the chart or on the chart is in true. And next week, we're going to talk about all of those compasses.
Got it.
Yeah, all our compasses on a boat are going to be magnetic.
Magnetic, yeah. But everything on the chart is true. So we have to be able to go back and forth.
Gotcha.
Is that called deviation?
Deviation, variation, yes.
Another question, Captain. Quick.
Yes.
So when you want to correct for the magnetic, does it change from geolocation to geolocation? Like if you're on different, it's not the same, is it?
Correct.
Okay.
It changes each location.
Okay.
And we will dive deep into
That's
that.
the chart for that, right?
Yes, you look on the chart for variation, then you have a deviation table specific to your vessel.
Awesome.
But
Thanks,
we're-
Captain. Have a good week. Thank you for today's class.
You're welcome. I'll post some videos of the rest of these. The answers are on Google Classroom. But I will put a video up. I didn't put it up last week because I thought my lecture kind of showed you all the answers. But I will post one this week. So shoot me an email if you have any questions, and let me know if you are still having trouble on Google Classroom.
All right. Thank you.
Thank you.
Thank you. Good night.
Sounds good. Thanks, Kevin. Have a good one.
Thank you.
Thank you.